Hello everyone, I am Dr. P.S.V.Shanmukhi, Associate Professor, Department of Physics, Aditya University. I would like to explain about the optical fibers, the modes of propagation. At the end of this lecture, student will able to understand the types of optical fibers and also the propagation of signal through an optical fiber. Optical fibers are classified into two categories, SMF, single mode fiber, and MMF, multi-mode fiber. What do we mean by a single mode fiber or a multi-mode fiber? Basically, coming to the first one, suppose it is an optical fiber core and say this is cladding the outer sheath buffer. Anyhow, say this is the axis of the cable. Actually, for the propagation of the signal through an optical fiber, the essential condition is the total internal reflection. The light ray should undergo total internal reflection. For that one, there is one essential condition that the light ray should make the angle less than the acceptance angle. That means the acceptance angle, say theta, that is A acceptance angle, it should be less than the acceptance angle. If the light ray is incident at the acceptance angle at the core and cladding interface, it travels along the boundary. If the light ray making the angle less than the acceptance angle, the light ray undergoes total internal reflection. If the light ray makes the angle more than this one, it escapes from the cable. That means the essential condition is the incident angle I should be less than or equal to the acceptance angle, so that it undergoes total internal reflection, it propagates through the cable. But one thing, this is an essential condition, but it is not the sufficient one. Means there is no guarantee for the propagation of the light, even though the light ray is making the angle less than the incident angle. There is no guarantee. What does it mean? Suppose let us imagine two light rays. These two light rays are making the angles less than the acceptance angle. Those two are making the total internal reflection. Here, these two light rays superimpose constructively. There may be a construct interference of light, there may be a destruct interference of light. If the light rays interfere constructively, then what happens? Those light rays will be propagated. If the light rays interfere destructively, such light rays will not be propagated. Means the light ray should make the angle less than the incident angle. At the same time, the light ray should interfere constructively. So, there are only some allowed directions. Along those directions only, the light rays will undergo construct interference, they will be propagated. In the other directions, the light rays are incident, even though less than the acceptance angle, then they will not be propagated because of the destruct interference. Those allowed directions are called modes of propagation. Some optical fibers allow only one allowed direction. Such kind of optical fiber is called single mode fiber. Some optical fibers allow more than one allowed direction. They are called multi-mode fibers. That means single mode fibers have only one allowed direction, that is axis of the cable. If the light ray is incident along the axis of the cable, it will be propagated. And whereas multi-mode fibers, they accept the light rays in several directions. So, there are some allowed directions more than one. Such optical fibers are called multi-mode fibers. So, basically optical fibers are classified into two categories as single mode fiber and multi-mode fiber. On what basis again they are classified? They are classified based on d by lambda value, where d is the diameter of the core, lambda is the wavelength of the light. Suppose here the diameter of the core, it is very small, order of 4 micrometers, then it allows only one allowed direction, then it is said to be single mode fiber. If d approximately 100 micrometers, then it allows more than one allowed direction, then it is said to be a multi-mode fiber. So, anyhow, these optical fibers are either single mode fiber or multi-mode fiber. They are characterized by one more parameter called the index profile. What is meant by index profile? Simply it is a graph. A graph is plotted in between the refractive index versus the radial distance of the material, nothing but thickness. So, here this is the graph plotted in between the refractive index is taken along y direction and the radial distance of the material is taken along x direction. Suppose based on this index profile, again two types of optical fibers are taken. That means step index fiber SI, another one GRIN, graded index fiber. What is meant by step index fiber? Suppose this is core and it is a cladding. I am taking the cross sectional view. This is the core of refractive index N1, cladding of refractive index N2. So from core to cladding, it is changing through a single step. The core refractive index is taken as N1, cladding refractive index is taken as N2. From core to cladding, the refractive index is changing through a single step. That's why it is called step index fiber. Whereas GRIN means graded index fiber. The graded index fiber means from core to cladding, refractive index changes gradually. Suppose this is the cladding and the core is taken as concentric layers. Core is in the form of concentric layers. Inner layer is denser than the outer layer. Go on like that. So between any two adjacent layers, total internal reflection is possible. So you observe the index profile for this one. It is a curved part. So from core to cladding, refractive index is changing through several steps or in a non-linearly, and in case of step index fiber, from core to cladding it is changing through a single step. So that is the index profile. That's why based on the index profile, optical fibers are classified into three categories. Initially, we have classified into optical fibers into two categories, single mode fiber and multi-mode fiber. Based on the index profile, again now all are classified into three categories. What are those three? Step index, single mode fiber; step index, multi-mode fiber; graded index, multi-mode fiber. In case of single mode fiber, there is only one allowed direction and also only step index is possible. Whereas in case of multi-mode fiber, both step index and graded index both are possible in this one. That's why total three types of optical fibers are there. They are single mode fiber, step index, single mode fiber, step index, multi-mode fiber, graded index, multi-mode fiber. So like that they are classified. Now coming to the propagation of the signal through an optical fiber. How the signal propagates? You observe the first one. This is the single mode fiber. In case of single mode fiber, basically it is step index only. So the core is taken, inner cylinder is core, the outer cylinder is taken as cladding. From core to cladding, through a single step it is changing. And moreover, light propagates only one allowed direction, that too axial direction. Suppose take the vertical direction, vertical way, the optical fiber. This is the axis, nothing but normal. When the light is incident on the normal, without suffering any deviation, it travels. That's why only it is supporting the axial direction. Coming to the multi-mode fiber, several allowed directions are possible. So this one is the propagation of the signal through the multi-mode fiber, moreover step index only. So the inner cylinder, outer cylinder, only two things are there. Here these light rays are called zigzag rays. Whereas in case of single mode fiber, that is called axial ray. First one is called axial ray and in this one they are called zigzag rays. Coming to the third type, multi-mode fiber, moreover it is graded index fiber. The refractive index is changing gradually. That's why in case of core, concentric layers are available between any two layers from inner to outer. Between any two adjacent layers, there exists the total internal reflection. That's why the signal is propagating like this. So this is the propagation of the signal through graded index fiber, this one, and this one is propagation of the signal through the step index fiber, moreover multi-mode. These are the zigzag rays, and in case of single mode fiber, this is the axial ray direction. So in that way, so coming to the summary of this one, actually here we have discussed the types of optical fibers. What are the different types of optical fibers? Basically single mode fiber, multi-mode. Later on step index and graded index fibers, both the multi-mode and the single mode fibers we have discussed. And also we have discussed the propagation of the signal through various fibers like step index single mode fiber, step index multi-mode fiber and graded index multi-mode fibers. All these things we have seen in this article. Thank you.